Okay, part 3 has to do with these linear equations and proportional or non-proportional stuff. Okay, so let's look at this one. It says, a beer first recorded the temperature of a solution at negative 13 degrees Fahrenheit. The solution then increased in temperature at 0.7 degrees Fahrenheit every minute. Okay, so let's back up and make sure you understand what's going on. So a beer is in a chemistry class and is putting chemicals together and watching stuff turn colors and explode and cool stuff like that. Okay, so the solution is a chemical mixture. So before he started the clock, all right, he put the stuff together, he made this solution and then he took the temperature at the very beginning, before anything happened. So at the very beginning, it was negative 13 degrees, okay? Then he started the clock. Boom. Start the stopwatch and noticed that the temperature increased 0.7 degrees every minute, okay? So that's important. Now, this particular problem, they gave you everything, so they went ahead and gave you the equation, all right? They told you what x is. They told you what y is. They showed you a table, right? And what the table is they picked some numbers, okay? I don't know why they picked those numbers, but anyway, they picked numbers for x and they plugged them in to the equation up there for x and solved for y. So these numbers they just picked, they just came out of nowhere, okay? Then they plugged them in to the equation from here, did math, and came up with the y. All right, and so they did that every time. Okay? So, any equation, whether it's linear or not, that's as you increase in math and get in higher math, you're just going to be doing this kind of stuff over and over again. Okay? Plugging and chugging is what I call it. What happens here is you come up with ordered pairs, points that you can plot on a graph and connect. Okay, so that's what your x and your y's are. But we didn't have to do that. All we have to know is this proportional or non-proportional? All right, so let me give you the clue. If they give you the equation and there's something added or subtracted at the, next to the x term, right? So you got this 0.7x and then you have this minus 13. Anytime you have something added or subtracted to the x term, it is not proportional. Never, never, never. So it is non-proportional. Okay, if there is a 0 or there's no x term, it look like that would be proportional. Okay, so that's the difference between proportional and non-proportional. Is you're looking to see if there is this thing, and what it is that times 0 or whatever, when x is 0, if y is not 0, then it's non-proportional. If x is 0 and y is also 0, then it's proportional. So that's how you tell if it's proportional or not. Okay? So here's another one where they give you just about everything. Okay, given y equals 1/3 x plus 4. Alright, they give you a table of values and ordered pairs. And you're supposed to choose the correct graph. So I'm just going to graph it for you. Okay, based on the ordered pairs. And then they want you to tell whether it's proportional or non-proportional. So before we do anything, from what I just said, because of that plus 4, what is it? Proportional or non-proportional? Hopefully you said non-proportional because of that plus 4. If that plus 4 wasn't there and it looked like that, it would be proportional. Okay? So what they did was they made a table, okay? And they just picked numbers. All right, and if you ever have to do this, you just pick numbers, and usually we pick some negative and a 0 and some positive, and we plug it into the equation. So we replace the x with the numbers that we picked, and we do the math, and we come up with a y. Okay, and so like I said a while ago, these numbers, the x's and the y's, are ordered pairs. And the ordered pairs are points that you plot, and you always do x first, then y. So these are all the x's and these are all the y's, and this guy goes together. Okay? So on a graph, the horizontal line, horizontal like horizon, is your x if it's not labeled, okay? And your vertical line up and down is your y. So if my first point is negative 6, 2, that means my x is negative 6 and my y is positive 2. So this is 0, and I'm going to go to my negative 6 on the x, and then I'm going to go up 2. Well, notice that these go up by 4s. You always have to pay attention to the graphs. So 2 would be right in the middle, right? So I'm going to put a point right there. Okay, and then the next one is 0, 4. So that one's easy. You go to the 0 and you go up to the 4. And then the next one is 3, 5. So positive 3x and a positive 5. Well, if this is 4 and this is 8, that would be 6. So we're just going to kind of guesstimate. We're going to say that's 5. Okay, and then the last one is 6, 6. So there we go all the way over to the positive 6 here and go up to the positive 6 here. Alright, and you can connect the dots, which is going to be difficult with me holding this camera here. But anyway, okay, beautiful. Alright, you would pick the graph that have those points on it. Alright, now then, and then we also, we already talked about this is non-proportional. Hopefully I spelled that right. Another way, if they just give you a graph to tell if it's proportional or non-proportional, is if it's a line and it goes through 0, 0, it's proportional. If it doesn't go through 0, 0, it's non-proportional. Okay? So, last one. Up here, you have to do a little bit of work. Okay? Given the table of values, substitute the change in the x and the change in the y into the formula and simplify. Choose the choose the y-intercept and choose the correct linear equation in y equals mx plus b form. State if the relationship is proportional or non-proportional. Okay, let's talk about this. This is a linear equation. Okay? The m, think of the word mountain. Alright? I'm just going to put mountain in quotes. People go to mountains and they ski down slopes. Alright? M is the slope or rate of change of the line, because I said this was a linear equation. B stands for y-intercept. Okay, why they picked a B, I still don't know. Except for when you're graphing a linear equation, you always begin at the y-intercept and then worry about the rest of it. So I always think a y-intercept is where I begin if I'm actually graphing. Okay? The y-intercept is always going to be, x is always going to be 0. And I'm just going to use B because whatever that number is, that's the point at the y-intercept. X is always 0. Okay? That's a B, not a 6. Okay. Alright, so that's what this stuff means. Now then, slope, rate of change, is always the change in y's over the change in x's. Okay? Change in y's over change in x's. That's the slope. So that's why they give you the x's and the y's, and the first thing I want you to do is find the change. Okay? So you can, I'm gonna add another column here. Okay? And because I want to show you, because these numbers are kind of funky, but I don't want you to get lost. Alright. So to find the change, you're gonna find what happens here. How do I go from -4 to -2? Okay, so you can either do mental math or you can go backwards and say -2 minus a -4. Alright, use your calculator if you're not so good with negatives. And that's going to be a positive 2. Alright, so let me just write that down. -2 minus a -4 equals 2. So that's your change in x. Alright, your change between -2 and 0 is you're adding 2 to get to 0. Again. Alright? Now see, they kind of changed some numbers here. I went from 0 to 6. So from 0 to 6, we're adding 6. And from 6 to 12, we're adding 6 again. And another way to look at it is do the last number minus that one. So 12 minus 6 equals, okay? So all those numbers are the change of x. Do the same thing for the change in the y, okay? You can take the second number and subtract the first number, negative 9 minus negative 18, and you're going to get a positive 9, okay? You can do mental math going, okay, I'd have to add 9 to that to get to 0, so I'm going to get to 9. Here, obviously I have to add 27. Here, maybe I don't know this in my head, 54 minus 27 is, I think it's 27. I did this problem earlier, but don't want to make a mistake. Yeah, I was right, 27. Okay, so right here they're showing you the change. The change should be the same because it's a line, all right, but the numbers are a little bit different, so let's do this. So m is you're going to take the change in the y's over the x's. So y over x, we're going to go 9 over 2. 9 over 2, that's 4.5. 9 over 2, that's 4.5. Alright, this one's 27 over 6. And it is also 4.5. And then this is also 27 over 6 equals 4.5. So the change in the x over the y is 4.5. Or, it's a big or, because a lot of times I want m to stay in fraction form. Especially if you're going to graph it, it's easier to graph stuff if you have this, the fraction, because then you know you got to go, up 9 and over 2 or whatever. Okay? So what you would do is really you would use the smallest fraction. So 27 over 6, if we reduced it, we can divide everything by 3. And a lot of calculators will reduce fractions for you, if you're not so good. Right, and that would be 9 over 2. Alright? So, or 9 over 2. So if you have the little, if it's multiple choice, or you have the little down arrow thing, and it doesn't give you 4.5, look for that. Okay? Look for that. So that's your m. Now your b, remember, is your y-intercept, well, where it begins, and it's always where x is 0. Okay? So in this particular graph, or table, sorry, they told you that when x is 0, y is 0. When x is 0, y is 0. So that's your b. b is 0. Now, if you didn't have numbers here, then what you would do is you would plug in 0 into your equation, assuming you had an equation. We're fixing to write the equation. And then you would solve for it. But I don't think we're there yet, so most likely they're going to give it to you. Okay? Alright. So, your equation is going to be this right here. The only thing that you're changing is the m, because that's what you found, and the b, that's what you found. So you're going to write the x and the y and the x. You're just going to leave them y and x. Okay? So, y equals, m is the slope or the change, right? And the change. Okay? I'm going to write it in the fraction form because that's probably what your answer selection would be. And that m is always multiplied to an x. Always, 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 always. Okay? And then it's always plus whatever the b is. Well, in this case, b was 0. Now then, we normally don't do that. Alright? So if you had multiple choice, this probably would not be a selection. So we can ignore the plus 0, and really our equation would be just that without the 0. So like I said in the last two problems now, is it proportional or non-proportional? There's no number, right? 0, it's a number, but it's not a real number, or it's not a number we care about, right? Poor 0. It's sad all the time. Anyway, there's nothing there. If there's nothing there, then it's proportional. Okay? So, go over your review along with this video, and then if there's something that I missed, just let me know, and then I will unlock your test and you can try the test again. Good luck.